Hello there, everybody. Right back where we left off at the Pythagorean theorem. And, this was what figured out almost 2,500 years ago by Pythagoras. And, he was a good geometry guy. He had some weird other ideas. I suggest you look it up. You might get a good chuckle out of what he thought of the world. But his big contribution, was the Pythagorean theorem, which only works for right triangles. So remember that. So there we have our square denoting right triangle. Anytime you see that, you automatically are allowed to assume it's a 90-degree right triangle. So we have where a squared plus b squared equals c squared, where c is the length of the hypotenuse and a and b are the lengths of the legs of the triangle. To solve the problems that use the Pythagorean theorem, we need to find square roots. So that harkens back to chapter 1 where we were using our radical. And remember, our radical with no number in the little saddle right there, we automatically assume that to be a positive 2, to be a square root. So let's say if m equals n squared, then the square root of m for n is greater than or equal to 0. For example, we find that the square root of 25 is 5 because 5 squared equals 25. We also know that one of the roots of 25 is negative 5, but we don't have negative measurements of sides of angles. So let's not worry about that right now. So using this definition of square roots to solve for the length of a side in a right triangle. So we know here, read the problem, identify what you're looking for, length of the hypotenuse, so c. So translate into equation. We know a squared plus b squared equals c squared, which translates to 3 squared plus 4 squared equals c squared. So let's work that out. 9 plus 16 equals c squared. 9 plus 16 we know is 25. Square root of 25, because we're dealing with positive numbers, 5. So hot dog. There we go. 3, 4, 5. That's a handy similar triangle. You'll see that one. If you stay in math, you'll see that the rest of your life. So Pythagorean theorem to find the length of the hypotenuse. This looks suspiciously similar to the last problem. This is where, eventually you'll see where similar triangles are so important. So here we're going to have 6 squared plus 8 squared equals c squared. So 6 squared is 36. 8 squared is 64. You add those two together, it's 100. So c squared equals 100. Square root of 100, 10. So you see these two examples between example 7 and try it 7 are similar triangles because the ratio of the lengths of their sides in every case is 2. Just wanted to point that out. So use the Pythagorean theorem to find the length of the longer leg. We have, let's call that longer angle or that longer side b. So we know that a squared plus b squared has to equal c squared. But in this case, we end up 5 squared plus b squared equals 13 squared. 25 plus b squared equals 169. So let's get rid of that 25 there. Minus it from each side. B squared equals 144. B equals 12. Yeah, it works again. More similarities. So in here, they want us to find the length of the short leg, which they've done with B. So same concept. So 15 squared plus B squared equals 17 squared. I believe 17 squared is 289. And 15 squared is 225. So 289 minus 225 is 64, which means the square root of 64 is 8. I did the math in my head well today. But that's all we did there. Here they give you a gazebo, but you don't get bothered by Kelvin building his gazebo. All we're interested in is the numbers here. So look, we have the triangles. We know the bracket here is 10 inches, and we have x, and we know that x equals 10. And what did I say? Bracket diagonally. How far below the corner should he fashion the bracket if he wants the distances from the corner to each end of the bracket to be equal? Approximate to the nearest tenth of an inch. So since we know our legs are going to be identical, we'll just call them both x. Now, does anybody know here what a triangle with two equal length sides is called? No, isosceles triangle. So any triangle with two sides that are equal in measurement is called an isosceles triangle. This one just happens to be an isosceles right triangle. So we already know that one angle in here is 90 degrees. So from this we know a squared plus b squared equals c squared. X has been defined, so x squared plus x squared equals 10 squared. Simplify it, 2x squared equals 100, x squared equals 50, x equals the square root of 50. So we can use our calculators to solve for that. B is approximately equal with rounding to 7.1. So you can check it, and it's pretty close in the check, so you know you've done that properly. Let's look at try at 9. John puts the base of a 13-foot ladder 5 feet from the wall of his house. How far up the wall does the ladder reach? All right, well, we drew a diagram. Nice little house. So this 13 foot is the ladder. So if we look at it, we know our right angle is between the house and the ground. So right where you see my cursor moving, there's our right angle. So the side opposite that right angle, so 13 is our hypotenuse. So 13 is C. And let's call what we're looking for B. That makes side A, which is one of the legs, 5 feet. B is the other leg. So we're looking for the value of the other leg. So we know A squared plus B squared equals C squared. In this case, we have 25 plus B squared equals 169. This is a problem we already had before. So we know 169 minus 25 is 144. That's what's equal to B squared. Take the square root, 12. Very, very simple, but we'll go through this. Key concepts here, supplementary and complementary angles. And then you have your glossary and the exercise set. I want you to go through all of these. I want you to do I want everybody to do all the problems in this. I don't care how bored you get. This you need to know. You need to know this inside, outside, backwards, upside down. It's just, so do that. I'd like to have that done for next Tuesday. That would be March 4th. So have that done. And we will end things for today on chapter 5.1.